Hello everyone and welcome to a new lecture. In this video we're going to talk about implicit differentiation. Okay, so what is implicit differentiation? Well, before we go into explaining what is implicit differentiation, let's talk about what implicit actually means. Okay, so if we have a function, let's say y equaling to x to the 2 minus 5x plus 6. This is an explicit equation because we have y and it is defined in terms of x. Okay, we have all the x's on one side and we have the y on the other side. It's explicitly defined. Okay, however, so this is an explicit equation. Okay, if I have y to the 2 plus x to the 2 equaling to 13, okay, this is an implicit equation because I don't have the x's on one side and the y's on the other side. So this equation, for example, is not explicitly defined in terms of x. We have x right here, we have y right here, and then we have a number. Okay? And the difference between them is just that. It is easier for me to find or to evaluate x right here. Okay, if I want to find what is y if x equals to 3, all I have to do is just to plug in 3 into the equation and it will give me y. However, here it will take me longer than that. Okay, so that is basically the difference between explicit and implicit. Okay, so now we know this. We want to know how we can differentiate implicit equations, how we can differentiate these kind of functions. So if I have y to the 2 plus x to the 2 equaling to 13 and I want to differentiate this equation in terms of x, okay, or in respect of x, what do? Do I treat y as a variable or as a constant, or how can I differentiate the function like that? Well, what you're going to do is, mechanically, I'm going to tell you the steps to differentiate implicit functions or to do implicit differentiation. Wherever you see a y, okay, you will treat it exactly as an x. Okay, so here we have y to the 2. If you have x to the 2, the way you will, or the way you would differentiate it is you'll bring the 2 down and then you'll subtract 1 from the 2. So basically you will have 2x because the power will be 2 minus 1, it will be 1. You will do the same thing for the y. You'll bring the power down, multiply it by whatever, and then you'll subtract 1 from the power. However, the only thing that you do is you'll put a dy dx after it. Okay, so the derivative of y to the 2 is 2y dy dx. However, the derivative of x to the 2 is 2x. Okay, so we have a plus right here, and the derivative of 13 is just 0. Okay, so that is the only thing that you do when you find or when you do implicit differentiation. After any y that you have, or after you take the derivative of the y, you'll put a dy of or dy over dx. That is what you do. And the idea behind this dy and dx is, so suppose we have this y to the 2 plus x to the 2 equaling to 13. So we have y to the 2 plus x to the 2 equaling to 13. We have this equation. Okay? So here the dependent variable is y, okay, and the independent variable is x. So y depends on x because if I put value to x, it will give me y. Okay, that is the equation. So basically here y equals to f of x. As simple as that. So instead of any y, I can put just f of x. So instead of this y to the 2, I can put f of x, however everything is squared, plus x to the 2 equaling to 13. I can put this thing right here. So if I want to differentiate this, or if I want to differentiate this equation, I'm going to take the differentiation of both sides of the equation. Okay, so I'll take the derivative of this side and I'll take the derivative of this side. Okay, basically, or d of dx of this side and d of dx of this side. Okay, d of dx of f of x raised to a power of 2 is you'll bring the power down, okay, multiplied by whatever you have, f of x, okay, and then you'll take 1 away from the power. So 2 minus 1 is just 1, okay, and then you're going to multiply by the derivative of the inside. The derivative of the inside is f of x, however, everything is differentiated. As simple as that. So basically this is the chain rule. Okay, plus 2x equaling to 0. So here I have 2 times f of x times f of x differentiated. Okay, so if I change back this into the y, f of x equals to y, so I will have 2 multiplied by y, okay, multiplied by y prime, okay, because this is f of x prime. This y prime that I have right here is just dy over dx. That is why after any y that I have, or after any differentiation that I do on a y in an implicit differentiation, I put a dy over dx. That is the idea. But the mechanical way is exactly that I told you. After any y that you take the differentiation of, you put a dy over dx. And the idea is the chain rule. The same thing, or the exact thing that I just showed you right here. If you put, for example, this equation right here, if you equal y to f of x, okay, since y is the dependent variable, then if you put f of x right here and you square it instead of the y being squared, this is the chain rule. You bring the 2 down. If you want to take the derivative of this, you'll put the 2 down, and then you'll take away 1 from the 2, and then you'll take the derivative of this. Okay, so it will be f prime of x. F prime of x is just dy over dx. Is the derivative, or it is the change that happens in y in respect of x. Okay, so f prime of x is just dy over dx. Okay, that's why after any y that you take the derivative of, you put dy over dx. Okay, that is basically implicit differentiation, and that's how you do it. Okay, so to give you an example, so just keep that in mind. After any y you take the derivative of, just put dy over dx. And sometimes they ask you to find, or when you do implicit differentiation, they ask you to find dy of dx of the equation. Okay, so basically you'll find dy over dx, and that'll be it. And in a second I'll show you how you can do that. Or basically they just ask you to find the y prime. Okay, so example 1, suppose I have y to the 2 times x to the 3 minus xy equaling to 5. Okay, and I'm asked to find dy over dx of this equation. Okay, how can I do that? Well, basically, what I'm going to do is I'm going to do implicit differentiation. Okay, I can find the derivative of each of these terms, and in that way I can find dy over dx. But first of all, I'll take the derivative of both sides. So I'll find the derivative of this side. Okay, and I'll take the derivative of this side. Okay, the derivative of this side is just 0, so I can just delete this and put 0 right here. Okay, the derivative of this, okay, so this is y to the 2 multiplied by x to the 3. Okay, so it will be the derivative of this multiplied by that, okay, plus the derivative of this multiplied by that. Okay, so it will be, so the derivative of y to the 2 is 2y. So after any derivative of y, I'll put dy over dx multiplied by x to the 3 plus y to the 2 multiplied by the derivative of x to the 3, which is 3x to the 2. That is the derivative of this term, minus. Here we have x times y. Okay, the derivative of x times y is the derivative of x multiplied by y plus the derivative of y multiplied by x. The derivative of x is just 1, multiplied by y is just y. Okay, plus x multiplied by the derivative of y. The derivative of y is 1. So it will be 1 times dy over dx. Don't forget the dy over dx after any derivative of y. So dy over dx equals to 0. Okay, so let me simplify this a little bit. So I have 2y dy over dx times x to the 3 plus y to the 2, 3x to the 2 minus y minus x dy over dx equaling to 0. So now what I'm going to do is I'm going to put all those terms that have dy over dx on the right hand side and then the rest on the left hand side. So from this I'll have 2y dy dx, or I can put just the x to the 3 right here. So 2x to the 3y minus x dy over dx. Okay, and then I'm going to put the rest of these on the other side, equaling to y minus y to the 2 times, or 3y to the 2 x to the 2. Okay, so here I can take dy over dx out. as a common factor. So I have dy over dx right here, and then I will have 2x to the 3y minus x equaling to y minus 3y to the 2 x to the 2. So from this, I have dy over dx to equal to y minus 3y to the 2 x to the 2 over 2x to the 3y minus x. That is dy over dx. Okay? As simple as that. And you may say, well, what does this mean? What is dy over dx? Well, I can explain it in an example. So the previous example that we had, which was x to the 2 minus y to the 2 equaling to 13, if I find dy over dx, I'm going to find the slope at any point of this circle. Okay? So if you give me an x and a y, I can plug in, after I find the dy over dx, I can plug it in into the implicit differentiation that I just found, and I can find the slope at that particular point. That is what this dy over dx means. It is the small changes that happen in y in regard to x. Okay? So that is the way that we find the implicit differentiation of this equation. Y to the 2 x to the 3 minus xy equaling to 5. The dy over dx of it equals to this. Or you can say that y prime of it equals to this. Okay? Let me give you another example. So let's delete all this. Suppose I have y to equal to sine of x cosine of y. Okay? Or actually sine of x plus cosine of y. And I want to find the dy over dx, or find me y prime. Okay, well, y prime actually equals to, or dy over dx actually equals to the derivative of this plus the derivative of that. The derivative of sine of x is just cosine of x, plus the derivative of cosine of y is minus sine of y multiplied by the derivative of the angle. Okay, so instead of this plus, I'll have minus sine of y multiplied by dy over dx. Do not forget this dy over dx. That is the whole point of implicit differentiation. So as you can see, sine of y has the dy over dx with it, or it has the y prime with it. I have to take it to the other side so I can find just dy over dx. Okay, so y prime minus, or actually plus, sine of y dy over dx equals to cosine of x. Okay, so instead of this dy over dx, I'll just write y prime, and if I take a y prime out, I'll have 1 plus sine of y, okay, equaling to cosine of x. So from this, I have y prime to equal to cosine of x over 1 plus sine of y, or dy over dx actually equals to this. That is the implicit differentiation of this equation. Do you see how easy it is? You just have to remember that after any y that you differentiate, you put a dy over dx, and after you do that, or at the end, when you reach a point such that you have terms that have dy over dx, all you're going to do is you'll put the terms that have dy over dx on the right hand side and the other terms on the left hand side. You will try to factor, if you can factor, the dy over dx so you can find the equation in terms of dy over dx. Okay? Meaning dy over dx equaling to something. Okay? Let me give you another example. So suppose I have, so example 3, I have this equation, x to the 2 plus 3x minus y to equal to 5. And I want to find dy over dx, or I want to find y prime. Okay? Find me this at 1 and minus 1 at a particular value. So I want to find the slope at 1 and minus 1 of this. So I'm going to take the derivative of both sides. So d over dx of x to the 2 plus 3x minus y equaling to the derivative, or so d over dx of 5. So right away this goes to 0. So here I have to find the derivative of x to the 2 added to the derivative of 3x added to the derivative of minus y, or minus the derivative of y. The derivative of x to the 2 is just 2x, plus the derivative of 3x is 3. The derivative of minus y is 1 times dy over dx. So just dy over dx equaling to 0. Okay, so now I can take everything that I have to the other side and leave the dy over dx on this side. So from this I have minus dy over dx equaling to minus 2x minus 3, or this is the same as dy over dx equaling to 2x plus 3. I can take a minus out and delete it with this minus right here. So this is dy over dx, but I want to find it at 1 and minus 1. Okay, I want to have it at 1 and minus 1. So I'll put 1 inside the function. I'll evaluate it at 1. So basically, since the x right here equals to 1, so it'll be 2 times 1 plus 3, which equals to 2 plus 3 equals to 5. So this is the slope of x to the 2 plus 3x minus y equaling to 5 at 1 and minus 1. Okay? As easy as that. And let me not forget, attached to this lecture, there are practice problems that you can download and practice as you want. Also, in the coming quiz, you can test your knowledge about implicit differentiation. But all you have to keep in mind is implicit differentiation, you have to find dy over dx or y prime of a particular equation. And all you have to do is, after any derivative that you take for any y, you put dy over dx, and at the end, when you have a lot of terms that have dy over dx with them, you'll put them on one side and the other terms on the other, and then you'll find the value of the function, or you'll find the function in terms of dy over dx. If they give you a particular x and y point, just like we have right here, just evaluate it into the equation, and like that you can find the implicit differentiation. And in case they give you a point, you can find the implicit differentiation at a particular point. Okay, so with this we come to the end of this lecture.